3 minutes ago, if you had been standing on the surface of a frozen moon 900 million miles from where you are sitting right now, you would have seen something no human eye has ever witnessed. A wall of ice, silver and impossible, catching light from a sun so distant it looks like nothing more than a bright star. That is not a metaphor. That is a real place. And 3 minutes ago, a signal carrying the final images from that place finished its 90-minute crawl across the solar system and landed, unannounced, in the inbox of a research team that was not expecting anything unusual at all. What they found broke the room into silence. There were no alarms, no press conference scheduled, no countdown clock ticking toward a dramatic announcement. Just a handful of researchers, staring at reprocessed frames on ordinary computer monitors, slowly realizing that the data in front of them did not match anything in the models they had spent their careers building. That is how the biggest discoveries in planetary science tend to actually happen. Not with fireworks, with a long, uncomfortable silence followed by someone quietly asking, "Are we sure this is right?" Because these were not simple photographs. These were the last transmitted frames from Cassini's archive, reprocessed using instruments and algorithms that did not exist when the spacecraft was alive, revealing detail buried inside the raw data for years. Nobody was supposed to find this. Nobody was looking for it. And yet here it is, published, verified, and already forcing planetary scientists to rewrite paragraphs in textbooks that were considered settled just months ago. Stay with me, because by the end of this, you are going to understand exactly why a spacecraft that died in 2017 is still making headlines in 2026, and why the very last images it ever sent back to Earth may be the single most important dataset humanity has ever collected about the possibility of life beyond our planet. To understand what just happened, you first need to understand what Cassini actually captured in its final hours, and why those final hours were unlike anything that came before them. Cassini spent 13 years orbiting Saturn, 13 years of photographing rings, mapping moons, and slowly building the most complete portrait of a planet that humanity has ever assembled. But nothing in those 13 years compares to what happened in its last 22 orbits, a sequence of dives so dangerous that NASA engineers gave it a name that sounds more like a military operation than a science mission, the grand finale. During the grand finale, Cassini repeatedly threaded a gap barely 1,500 miles wide, the narrow space between the top of Saturn's atmosphere and the inner edge of its rings. No spacecraft had ever gone there. No one knew what was waiting. Engineers built a makeshift shield out of the spacecraft's own antenna, angling it forward like a knight raising a shield before a charge, just in case that gap was filled with ring debris capable of shredding the instruments in an instant. It was not. What was waiting instead was something far stranger than debris. As Cassini plunged through that gap orbit after orbit, its cameras and sensors recorded a version of Saturn that no telescope on Earth and no previous mission had ever been close enough to see. And on its very last pass, just hours before mission controllers commanded the spacecraft to point its antenna away from Earth one final time and begin its irreversible dive into the planet's atmosphere, it captured a sequence of images that were, at the time, simply filed away as beautiful farewell photographs. Nobody in that control room in September of 2017 understood what they were actually looking at. It has taken nearly a decade and a small army of researchers combing back through the raw telemetry to understand it. Here is the first piece of what they found, and it alone would have been enough to make headlines on its own. Hidden in the final wide-angle frames of Saturn's night side, scientists identified faint structures rippling across the upper atmosphere that had never been cataloged before. Not clouds, not storms in the traditional sense, something that behaves more like a standing wave, a pattern that repeats with uncanny regularity every 10 hours and 32 minutes, a number that happens to match almost exactly with the mysterious radio signal Cassini had been picking up. From Saturn's interior for years, the signal scientists have spent 2 decades trying and failing to fully explain. For the first time, that radio rhythm and a visible, photographed atmospheric structure line up. 2 separate lines of evidence collected years apart, using completely different instruments, are now pointing at the same hidden clock ticking somewhere deep inside Saturn. Researchers describe it as watching 2 unrelated witnesses to the same crime finally agree on the same story. That alone rewired how scientists think about Saturn's rotation. But it is what came next, buried just a few frames later in that same final sequence, that actually stopped the room. Because in the very last close-up images Cassini ever took of Enceladus, the small icy moon that made global headlines years earlier when Cassini discovered geysers erupting from its south pole, researchers spotted something in the fine structure of the plume that nobody had noticed before. Not because it was hidden, because nobody had the tools to properly resolve it until reprocessing techniques developed in the last 2 years finally caught up with the resolution of the raw data. What they found were braided filaments inside the plume itself, threads of material twisting around one another as they rose from the moon's cracked surface. patterns that match laboratory simulations of material erupting from a liquid reservoir under variable pressure, not a simple, steady vent. In other words, Enceladus's ocean is not calmly leaking into space at a constant rate. It is pulsing. Something beneath that ice is breathing, expanding and contracting on a rhythm that leaves fingerprints in the very last photographs Cassini ever took of that world. Scientists who reviewed the finding used words that planetary researchers almost never use in public. One called it the closest thing to watching a living system function that anyone in the field has ever documented outside of Earth. Another, more cautious, simply said the data demanded an explanation that current models of Enceladus's interior cannot yet provide. Let that sit for a moment. A moon smaller than the distance across the United States, sitting nearly 1 billion miles from the sun in permanent, bone-crushing cold, appears to have an interior that behaves less like a frozen rock and more like a body with rhythm, with pressure changes, with an internal mechanism driving material to the surface in pulses rather than a slow, passive drip. And this is where the story turns, because pulsing plumes are not simply a curiosity. They are a clue about what is happening far below the surface in the ocean itself. When researchers modeled what kind of internal structure could produce a plume that behaves this way, the leading explanation is not a simple body of water sitting quietly under a shell of ice. It is an ocean floor riddled with fractures, actively venting heat and material into the water above, through structures that behave remarkably like hydrothermal systems on the floor of Earth's oceans. The same kind of environment where, on our own planet, life is believed to have first taken hold in complete darkness, powered not by sunlight but by chemical energy rising from inside the planet itself. Cassini was never built to detect life. Its instruments were designed to measure magnetic fields, count particles, and photograph geology. And yet, in the very last images it ever transmitted, hidden inside patterns too subtle for anyone to notice in 2017, it appears to have captured indirect evidence of an active, energetic, chemically rich environment on the ocean floor of another world. That is not proof of life. No scientist involved in this research is claiming that, and any responsible account of this discovery has to be honest about that distinction. But it is proof that the conditions many scientists consider necessary for life to begin are not just theoretically possible on Enceladus. They appear to be actively happening right now, captured in the last frames a dying spacecraft ever managed to send home. There is a third piece to this story, and it might be the strangest of all. Buried in the calibration data attached to those final images, the kind of technical housekeeping information that scientists usually skim past without a second thought, researchers noticed something odd about the way sunlight was scattering off tiny particles between Saturn and its rings in that final sequence. The scattering pattern did not match what should have been there if the space between the rings and the planet was as empty as everyone assumed. It wasn't empty. Cassini's last images captured faint evidence of a diffuse population of nanometer-scale particles occupying that gap. A kind of thin, invisible fog of material, far too small to see directly, but large enough to subtly bend the light in Cassini's very last photographs. Nobody built an instrument specifically to detect this. Cassini found it by accident in the last place anyone thought to look, in data that sat unread and unexamined for years, because nobody had a reason to look that closely at engineering calibration frames. That discovery matters because it suggests the gap between Saturn and its rings, the same gap Cassini risked its own destruction to fly through 22 times, is not the clean, empty corridor scientists believed it to be. It is filled with an almost invisible haze of material constantly raining down from the rings into the planet, adding yet another piece to the growing picture of just how dynamic, how alive this system actually is. There is a fourth thread to this story, and it comes from somewhere nobody expected to look at all: Saturn's magnetic field. For decades, scientists have known that Saturn's magnetic field is strange. Every other planet in the solar system, including Earth, has a magnetic field that is noticeably tilted relative to its axis of rotation. Saturn's is not. It is aligned to within a fraction of a degree, so close to perfect that, according to the standard theory of how planetary magnetic fields are generated and sustained, it should not be able to exist at all. A field that perfectly aligned should have quietly collapsed billions of years ago. In the final days of the grand finale, as Cassini skimmed closer to Saturn than any spacecraft ever had, its magnetometer took the most precise measurements of that field ever recorded. And buried in that final data set, researchers recently found a faint, wobbling signature, a signal so small it was initially dismissed as instrument noise, that may finally explain how the field manages to survive. The current leading theory, still being debated in journals through 2025 and 2026, is that there is a hidden layer deep inside Saturn, a kind of stable shell of helium rain, quietly canceling out the tilt that should be there and keeping the field locked in place. If that theory holds, it means Cassini's final orbits did not just photograph a beautiful planet, They caught the interior of Saturn in the act of hiding one of its own secrets, a mechanism that keeps an entire magnetic field stable, recorded almost by accident in the last data the spacecraft ever sent home. And then there is the halo. In a paper that surfaced in late 2025, a team working through Cassini's final cosmic dust readings identified something that had gone completely unnoticed for years. A vast, faint envelope of microscopic particles surrounding Saturn's rings, extending out to nearly 3 times the width of the rings themselves, invisible to every telescope that has ever pointed at the planet. The only reason anyone knows it exists is because Cassini physically flew through the edge of it during those final dangerous orbits and recorded the impacts. Every photograph of Saturn you have ever seen, every image and every textbook, every wallpaper of those famous rings has been incomplete. The real structure surrounding the planet is larger, messier, and stranger than anything ever captured on camera, and we only know that because of measurements taken in the spacecraft's last weeks alive. 3 separate discoveries became 4. A rhythmic pulse hidden in atmospheric structure, a breathing plume on a moon that should be frozen and still, an invisible haze filling a gap once thought to be empty, a hidden internal shell keeping an impossible magnetic field alive, and a dust halo 3 times the size of the rings themselves, sitting there the entire time, unnoticed. All of it sitting quietly in the very last images and measurements Cassini ever transmitted. All of it unnoticed for years, and all of it surfacing now, within months of each other, as researchers finally have the tools and the patience to look closely enough. There is a 5th piece of this puzzle, and unlike the others, it is not a discovery of something new. It is a correction. And in some ways, corrections are more unsettling than discoveries, because they mean something we were confident about was simply wrong. For years, the working assumption about Titan, Saturn's largest moon, was that beneath its thick orange atmosphere and its lakes of liquid methane, there had to be a substantial global ocean of liquid water, similar in scale to the one believed to exist under Europa's ice. Titan is bigger than the planet Mercury. It has internal heat. It has tidal flexing from Saturn's gravity. Every condition that should produce a deep ocean appeared to be present. When researchers went back through Cassini's final radar and gravity measurements using updated models in late 2025, that assumption did not hold up. The interior of Titan appears to behave in a way that is inconsistent with a large, uniform ocean of liquid water sitting beneath the crust. Something about the moon's internal structure is different from what nearly everyone in the field expected, and right now nobody has a clean replacement explanation. It is not that Titan turned out to be boring. It is that Titan turned out to be strange in a completely different way than anyone had prepared for. And the only reason we know that is because someone was willing to look critically at a decade-old dataset and admit the old model no longer fit. That is the quieter, less flashy side of what is happening with Cassini's archive right now. It is not only producing new wonders, it is forcing corrections, forcing scientists to admit that confident assumptions built on partial data do not always survive contact with better analysis. And that, in its own way, is just as important as any single discovery, because it is a reminder that even a mission as successful as Cassini did not hand us a finished picture. It handed us a puzzle with more pieces than anyone realized, and researchers are still sorting out which pieces fit where. This is the part of the story that should genuinely unsettle you in the best possible way. Cassini's mission ended in September of 2017. The spacecraft itself no longer exists in any physical sense. It burned apart in Saturn's upper atmosphere, deliberately, on command, so that it could never accidentally contaminate a moon that might harbor life. And yet, 9 years later, it is still generating front-page scientific discoveries. Not through new observations, through old ones, finally being read correctly. Every telescope, every future spacecraft, every mission currently being designed to visit Enceladus or Titan or any other icy moon in the outer solar system is being shaped, right now, by what researchers are still pulling out of Cassini's dead archive. The European Space Agency has Enceladus near the top of its list for a dedicated mission, specifically because of findings like these. NASA's next generation of ocean world missions is being designed with instruments built specifically to look for the kind of pulsing, breathing plume behavior that Cassini only barely managed to photograph on its way out the door. In other words, the questions that will define planetary science for the next 30 years are being written today, based on images taken by a spacecraft that has been gone for almost a decade. Think about what that actually means. Somewhere in a server room, on hard drives that have not been touched in years, there are almost certainly more discoveries like this one still waiting. Cassini returned more than 400,000 individual measurements across its mission, an amount of data so large that even now, with entire research teams dedicated to nothing else, scientists estimate it will take another decade or more before all of it has been properly examined. That means somewhere in that archive, right now, there could be evidence of something we have not even thought to ask about yet. A pattern nobody has noticed, a signal nobody has cross-referenced, a photograph technically already public, already sitting on a server, that nobody has looked at closely enough to understand what it is actually showing. The 3 minutes at the start of this story were not a metaphor for suspense. They were a description of physics. Light and radio signals take roughly 80 minutes to cross the distance between Saturn and Earth. The final images Cassini ever took were already old, already history, the moment they were captured. Because by the time anyone on Earth could look at them, the spacecraft that took them had already been gone for over an hour. Every single thing you are looking at when you look at a picture of Saturn is, in a very real sense, a message from the past, arriving late, carrying information about a moment that has already ended. And that is exactly why this matters so much right now. Because we are not looking at new images, we are looking at old ones. Finally understood. The universe already told us what was happening on Enceladus, in Saturn's rings, in that narrow, dangerous gap Cassini threaded 22 times before it died. It told us in September of 2017. We simply were not ready to hear it yet. We are ready now, or at least we are more ready than we were. Every year the instruments used to reprocess this data get sharper. Every year the models used to interpret what that data means get more sophisticated. Every year someone goes back into an archive that most people assumed had already given up everything it had to offer, and they find something that changes the conversation all over again. Cassini's last transmission reached Earth on the morning of September the 15th, 2017. By the time that signal arrived, the spacecraft itself had already been destroyed for more than 80 minutes, vaporized in Saturn's atmosphere, gone. And yet its voice kept arriving, kept speaking, kept teaching, long after the thing that made the sound had ceased to exist. 9 years later, it still has not stopped. The final images did not mark the end of what Cassini had to tell us. They marked the beginning of a conversation that is still going on, one careful reanalysis at a time, one overlooked pattern at a time, one research team at a time, finally noticing what was there all along. We send a machine to the far edge of the solar system to look at rings and moons and magnetic fields. What it sent back, in its very last breath, might turn out to be the closest thing we have ever found to a message pointing us toward the answer to the oldest question anyone has ever asked. Are we alone? It is worth sitting with that question for a moment rather than rushing past it the way headlines usually do. Cassini was never asked to answer it directly. Nobody built its cameras to search for biology. Nobody wrote its mission plan with the word life anywhere near the top. It was sent to measure, to map, to photograph, to do the quiet, patient work of characterizing a planet and its moons in as much detail as the technology of the late 1990s and early 2000s would allow. And yet, in its final hours, without being asked to, it appears to have handed us some of the strongest circumstantial evidence we have ever collected, that the ingredients and conditions for life exist somewhere other than Earth. 3 minutes ago, the answer to that question got a little more complicated. And somewhere in an archive that is not finished being read, on hard drives that have already given up secrets nobody expected to find, the next answer is already sitting there, waiting for someone to look closely enough to see it.